Right. So, I'm very glad to welcome you and everyone to this talk. I'm Paolo Valleri, and today I'm going to talk about what we have done in Bolzano, such as monitoring vehicular traffic through the detection of the Bluetooth in-car devices. So, probably you know better than me. Nowadays, in our cars, we can find one of these devices. They are just there to simplify the interaction or our phone while we are driving. So the simple things here is that the Bluetooth protocol says that if you want to connect a Bluetooth device, you have to discover it. And when you make a request, you have to discover a device. The device, it's up to the device to decide if it's the case to reply or not. So if the device is set as visible, he will reply. Otherwise, he will drop the request. So given that, the fact is that all the devices listed in the previous slide are set as visible, just to be more user-friendly. So this means that if we make an active query, such as we are just looking for new devices, we will get a response. So the simple idea of this talk is just discover new Bluetooth devices, then couple each response with the current timestamp, and then finally analyze the data gathered. It's really an easy idea, but is it worth to monitoring vehicular traffic through the detection of those in-car devices? So in Bolzano, we have done several real empirical devices, such as on one roadside, we were counting the car by hand, while on the other side, we were using our Bluetooth prototype. And we got that with this system, we are able to collect at least a quarter of the whole vehicle flow. So given these premises, I'm going to spend the rest of the talk to answer to these three questions. So why is it really needed to monitor in the traffic? And then, so which technologies have I used? And then finally, I will show some results. But of course, I have only 15 minutes, so let's hurry. The first question, why is it needed? So in Bolzano, I'm working on the Integrin project, and the Integrin project aims in improving the traffic flow, not only to reduce the traffic jam, but also to reduce the pollution. But in order to reach this big task, we need to gather data about traffic, meteo, a lot of data. For this reason, I start to think about how we can gather data about traffic. But when we talk about traffic data, we have two big fields. The first one is the simplest one. So we just count the car passing through a specific point. Or on the other hand, we have a really more complex one in which we are trying to estimate the travel time from several points in the city. And when you have all those points, we can understand the travel time and put all this data in a matrix. And this matrix is called origin-destination matrix. So nowadays, all the municipality to create a origin-destination matrix use camera. But these cameras are very expensive, but also they are really difficult to deploy because they must be put above the roadway. And then they need also the power cable, they need the connectivity, and so on. For this reason, I start to think about something that could be done more easily, dynamic. And so we finally arrive at which technology have I used. So this is our prototype working in Bolzano, and I like to call this the white box. it's a white box? Because it's not black, and the main difference okay, the main difference that a white box, we can open it and we can see the hardware, but not only the hardware, we can see also the software. All the prototype is powered by FOSS tools. So from the white box, it's composed of a Raspberry Pi, a Bluetooth device, then we have a battery and a converter. On the other hand, from the point of view of software, we have the operating system. I just used Raspbian. Then we have a Blue Log. Blue Log is running on the prototype, and is actually inquiring for it's the tool that is discovering the new devices. And then we have vTraffic, which is just a web application that show the analysis that we have done. So I will avoid to list all the feature of this awesome card, because probably you already know better than me this device. But here the point is that we have used this card not only because it's really cheap and it's very small, but also because it consumes just a bit of energy. And this is given that we had at least 2 days of lifetime, which actually was enough for doing a really empirical test. So while from the point of view of software, we have, I already told you, we have Blue Log. Blue Log is initially developed by Tom Nardi, and actually is just discovering for new device. And each time he finds a device, he mark the current timestamp on a log file with the MAC address of the Bluetooth. So as you can see here, the code, all the code can be summarized with this line, the HCI inquire, which comes from the Bluetooth library. He's just making the real query to the other device, and then the rest of the code is just logging the MAC address found and setting up the Bluetooth. While for vTraffic, vTraffic is a web app, in particular is a Web2Py application. It's written in Python, and I developed this application just to draw the function to analyze the data, the real data. But without spending too much time with this application, I invite you to visit this website where the application is running, and of course, if you click on compare or origin destination, you will find all the analysis that we have done. So before finish the talk, what kind of result I've got? So the most important experiment that we have done in the month of December was putting 2 different prototypes, 1 3 kilometers away from the other one. And the idea here was to understand the average travel time to pass through A and B. And to do that, we have just collect all the MAC address of all the Bluetooth devices discovered, and then in A, and then we have, from the set of the MAC address, we have seen which one was also in the set of B. And given that, we have drawn these 2 lines. And as you can see, these 2 lines come from it's from the 7th of December, and the other one from the 14th of December. Both of them are Fridays. But as you can see, along the day, the shapes are almost similar, but then something is changed. It's changed after at 6 p.m. So here the point is that we in Italy, the 8th of December, it's an annual holiday. And a lot of tourists used to come to the city of Bolzano to spend the long weekend there. And so the the blue line, it's of course of Friday, 7 December, in which so we have got a lot of tourists that came to the city, and so they hold this new flow, traffic flow. We got the average travel time was increased. Okay, so for the next step, we have just started, so we have a lot of next step. So as you probably have understood, sorry, I done just 2 days deployment, just short times deployment, because the prototype was powered by a battery. So the first next step is about making a very long deployment. And to make a very long deployment, the first thing is that we need a solar panel. But the solar panel then is not enough, because if we have a long deployment, we want also to have real data. So real data coming from the prototypes. So we need the connectivity, so we have somehow to add a Wi-Fi or a 3G device. And then from the point of view of software, BlueLog needs a better system to cache the device found, and VuTraffic, something to improve the graph and the map navigation. And so this brings me to the end of the presentation. Today I'm presented just an alternative approach to monitor vehicular traffic, and the good thing is that all the system is powered by FOSS tools. So it's not already ready for the production, but we hope that if someone is able to help us, we will be able to deploy to create something that a lot of municipalities we will be able to use. So thank you very much for your attention, and looking forward to meeting you on GitHub.